¿Cómo estás, amigo? Yo todavía estoy cansado del día.
Okay, this lesson is for extra credit. If you guys can do this, you get a 5% boost in your grade almost. 4.5 probably. And what we have is this is the first thing you need to be able to do. If this is 14 Newton of force and the angle here is 28 degrees, can you solve for this part right here? So these are your steps, so katoa, and we need sine equals opposite, because that's what we want, over hypotenuse, because that's what we know. Sine 28 equals this. Hypotenuse, sine 28 equals the opposite. So 14 sine 28 equals the opposite, and that becomes 28 sine times 14, 6.57. Okay, if you are not familiar with this step, you need to go back and watch the intro video. And we're going to solve for the x and y components of an applied force vector or arrow, and then add force vectors that are in 2 dimensions and not at right angles. These are what you need to be able to do to get credit for this. And here's your vocab. So the first thing is you can do this on whatever page you want.
You want the door open?
I'm fine. So the components are at angled forces. So first of all, what are components? Components are kind of, if you break them down, this is mostly up and a little forward, or mostly forward and a little up. And you can think of it like if you were to kick a soccer ball, its flight wouldn't be very high, but it would be far because you kicked it with more forward force in the x, than you did with up and down force in the y. Or if you kicked instead, like a drop kick, like a goalie might do, now you have a very high flight and not very far, because there's a little bit in the forward direction and a lot up and down. These are different components of this resultant angle. This is called the resultant. We talked about this during the displacement. Resultant vector. This is the component in the x, component in the y. So let's add an adding force review. If they're in 1 dimension, it's pretty easy. 30 and 10, that's a net of 20. So we just add them together. The opposite subtract. If it is in 90-degree angles, perpendicular, then a squared plus b squared equals c squared. And we've got 8 squared plus 6 squared, 64 plus 36. 100 equals c squared, square root. And the resultant is 10. But what if it's not at a friendly angle? What if we have one that's nice, but one that's kind of not playing very fair, like 8 degrees right here? We can't really add them up. We have to go through the following steps. Okay, step 1. So write these down. Rules for adding forces at weird angles. Number 1, break up the forces into x and y components. So if we could imagine this right here, we've got 2 forces. We've got F1 and we've got F2. This would be F1y, F2y, F1x, F2x. So if we know these, then we can go to the next step. We can add up the individual components of each force so that you get a net F in the x and a net F in the y. So if this adds up to 10, and this adds up to 2, and the components of this one are in the opposite direction, we'll say this looks to be about the same, 2 newtons, and this seems to be about 3 newtons. Well, then we can add these up. We can add up the 2 red ones. They're going to cancel each other out. So our net y, Fy net, is overall plus 8 newtons. And our Fx net equals, we'll go minus 1 newtons, or just 1 left. And the plus just means up. So now we have our net change. We added up the up and down, and we added up the individual left and right components. So you could even look at it like a formula, like this. Fx net equals Fx1 plus Fx2. Same with the y. Fy net equals Fy1 plus force y2. Next, take the net Fx and y and combine them into a new resultant force and angle. So we have find the resultant. This is part 1 over here. This was 1 newton. This was 8 newtons. And now we can find the resultant. A squared plus b squared equals c squared. So we've got, plug these numbers in to our Pythagorean theorem. 1 plus 8 squared is 64, c squared equals 65, and then square root. And this becomes 8.06, which makes sense because it's mostly up with only a little bit over. And now we need to solve for the resultant angle. So you can pick either one. I like this one. I like the 1. So we know our hypotenuse is 8.06. We know this is 1 newton. Now we need to find this angle right here. We need to find theta. We know the opposite and the adjacent. You don't know why this is hypotenuse and adjacent. If you don't know why this is hypotenuse and adjacent, you need to go back and review. So, sine, ka, toa. Which one has hypotenuse and adjacent? Cosine. Cosine theta equals adjacent over hypotenuse. Cosine theta equals 1 over 8.06. And now we need to do inverse cosine. Cosine inverse here. And this will cancel. And now theta equals cosine inverse of this stuff. And here's how it kind of looks on your calculator. 1 divided by 8.06 equals, and then inverse cosine. So it looks like this with a little 1. 1.12 degrees. The angle here is 0.12 degrees. Sorry, I forgot to push the button. Inverse cosine is 82.8 degrees because it's a really high angle. 82.8. So now we know the force and the angle that it's acting at. We'll come back more on that in a second. Let's look at a real example now. Okay, this might be something that you see on a test. First thing to do is break them up into components. So let's take a look. We'll do them one at a time. Here's the first one. I want to know F in the y direction, and what's the force in the x direction. So this would be hypotenuse, and this would be the adjacent. So cosine theta equals adjacent over hypotenuse times the hypotenuse this erases. Hypotenuse times cosine theta equals adjacent. 8 times cosine 32 equals what we want. Calculator. 32 cosine times 8 6.78 degrees. So I know Fy1 equals 6.78. Now I need to find this one over here. I could just as easily move this force up over here, F of x1. Now I'm going to use sine theta equals opposite over hypotenuse. Let's clean this up. So what I did is I've got this force right here, F in the x direction. But in order to make it in a triangle, I can just move it right up here. And now it's the opposite that I'm looking for. So times hypotenuse, sine theta times hypotenuse equals the opposite that I want. So we have 8 sine 32 equals what we want. By the way, this is 6.7. Calculator. 32 sine times 8 equals 4.23. So we have F in the y1 equals 6.7, F in the x1 equals 4.23. These problems take about a whole page, so get used to it if you're going to practice these. That was just part 1. Now we have part 2. We have to do the same thing over here. Cosine theta equals adjacent, right here, F in the y. This is the adjacent, over hypotenuse. Hypotenuse cosine theta equals adjacent. 15 cosine 40 equals what we want. 40 cosine times 15 equals 11.49. And now let's find this force, the x direction. Sine theta equals opposite over hypotenuse times the hypotenuse, 15 sine theta, calculator, 40 sine times 15 equals 9.64. Alright, let me hold on a second. So we've got Fy2 equals 11.49. Fy1 equals 9.64. Now here's where we can make a mistake. Let's remember, in the original picture, both of them are going up a little bit. So the two F in the y direction ones are going to be positive. But in the x direction, they're opposites. So we have to call one negative. So let's go back to our page. Let's add up these vectors and close this puppy out. These add together equals, let's find out the total y direction. 6.7 plus 11.49 equals 18.19 newtons. In the other direction, one's stronger, so I'm going to call this positive and this negative. I can just choose. 9.64 plus minus 4.23, that was close, equals 5.24, 41. These are our, we have a total of 5.41, and in the y direction way up here, we have an 18.19 newtons. And now we can find the resultant using a squared plus b squared equals c squared. So we plug in our numbers, square this one, and you get this down here. Square 5.41, and you get that number there. Add them together, and then finally square root equals 18.97 newtons. That's your result. $18.97. Now let's find the angle. 18.97, and we had what? What was over here? Back up. 5.41. And we need to find this angle, because it was mostly to the right and then mostly up. So we've got the adjacent and the hypotenuse. Cosine theta equals adjacent over hypotenuse. Theta equals inverse, because we have to move the cosine over here. Cosine -1 adjacent over hypotenuse, or cosine inverse adjacent 5.41 over 18.97 equals 73.4 degrees. Okay, that's just part of it. Underneath the blog, there'll be some practice questions for you to do, and then there's going to be another example posted shortly. That's more like what you'll see on the test, and we're just getting warmed up here. The test one will be a little bit less kind of arrows and more thinking, but I think it'll make more sense with actual objects and stuff, which is why I like physics, because it's math plus real stuff, which makes it a little more doable.